Today in Barcelona, this team of elite engineers is embarking on an epic endeavor.
Like magic, no?
They're attempting to build an extraordinary and complex superstructure. The world's tallest church.
When the towers will be finished, the skyline will change.
With a unique, untested construction method, using more than 170,000 tons of stone. When complete, Sagrada Familia will soar more than 565 feet tall and become one of the world's most boldly designed churches.
It's a big project, unique.
I walked in and it was like goosebumps.
To build this masterpiece, the team must battle deadly winds.
A strong wind can take down the crane.
It would collapse, so it just isn't an option.
And extreme heights.
We can lift. It's impossible. You are crazy.
We cannot afford any delay, any disaster, any mistake.
This incredible temple ranks in a league of ambitious engineering wonders that are bigger, faster, taller, and more advanced than anything ever constructed before. This series charts the inside story of the extraordinary race to build these giants. In Barcelona, one of the world's most historic and beautiful cities, workers have been laboring across 5 generations to build one of the most architecturally complex churches ever conceived. Sagrada Familia. Only partially built after 135 years, and soaring 330 feet tall, this awe-inspiring church already attracts 4.5 million visitors a year.
You'll come in and it'll take your breath away like this, but it's still not done yet. There's so much more to be done, and obviously outside you see the cranes doing building work, and so it'll be interesting to see how it turns out when it's finished.
But now, the end of this extraordinary build may finally be in sight.
We are going to be the last generation finishing this project.
Building work began on this ambitious church in 1882. Workers first built on the foundation of a traditional Gothic crypt. The temple's nativity facade, with its 330-foot-high bell towers, were finished in 1936. It's taken over 50 years to build the epic Passion facade. Then construct the vast central nave, vaulting and transepts. To form the launchpad for 6 mighty towers yet to be built. Today, they're attempting to finally complete this giant, using the funds generated by the 12,000 tourists that visit each day. Following in the footsteps of generations of architects before him, Chief Architect Jordi Fowley has been building up his dream team in the race to finish.
When I started my work here, only there are 6 people in the office. Now, 40, because it's a big project, unique.
Jordi's biggest challenge, complete the basilica with barely any plans. Sagrada Familia's original visionary architect, Antoni Gaudi, died almost 100 years ago, and few blueprints have survived. It's a great engineering mystery. They've got this far by copying old photographs of models and 100-year-old sketches.
It's important for us to be faithful to Gaudi, because Gaudi was a genius.
Gaudi was a true architectural maverick, pioneering unique geometric forms, inspired by the nature around him, trees, animals, mountains. He worked in a style never seen before or since.
Gaudí considered himself as a collaborator of God. The architecture of Gaudí is architecture with life, with natural forms, with color, different from another architecture.
This is Gaudi's vision. The giant Jordi and his team must somehow complete. Three huge facades will tell the story of Jesus, representing his life and teachings. 6 enormous central towers will almost double the height of the temple, making it the world's tallest church, at 565 feet tall. Costing an estimated £900 million and almost 145 years in the making, Sagrada Familia will be one of the world's most extraordinary structures.
Now we are focused in the construction of the 6 central towers. When the towers will be finished, the skyline of Barcelona will change.
Completing Sagrada Familia involves a series of unique engineering challenges. They plan to raise the towers in levels, formed from pre-assembled panels. Most panels will be made up of 16 blocks of stone. The team must construct spiral staircases inside 4 of the towers as they rise up. Elaborate stone friezes and exquisite stained glass will adorn the larger towers. The team is aiming to complete the Sagrada Familia before the centenary of Gaudi's death, just 9 years from now. The first challenge: source the stone to build the towers and facades. Gaudi's workers used local stone from the mountain of Montjuic, a unique multicolored stone.
You can see a stone of Montjuic can be red, can be gray, can be kind of yellow, close to orange, brown, dark gray. That gives a very rich colored wall.
But Jordi's team has a massive problem. The Montjuic stone quarry is now closed. So they must find a way to replicate the look of Montjuic stone.
We need to get the same concept as Gaudí. In the case of the towers, we decided to mix different kinds of stones with different kinds of colors to try to reproduce the same wall. This is like pixels on the TV. If you get so close, you see every pixel on every color. When you go out, you see one uniform color. We have to create this effect on the towers.
So Pau is sourcing the stone for the towers from 70 quarries around the world. Granite blue Bahia from Brazil, red porphyry from Iran, and the only quarry that can deliver the right shade of light brown buff gritstone in Lancashire, England.
We've had a call from Barcelona wanting to supply stone to the Sagrada Familia. We thought it was a hoax, to be honest. We thought it was a joke.
Quarry manager Emma Armstrong must deliver over 300 tons each week for Sagrada Familia.
The quality of our stone is absolutely critically important to the project in Barcelona, because if it wasn't of the strength and resilience as it is, basically the towers wouldn't stand up on their own, they'd collapse.
It takes great skill to extract this high-grade stone. Creating even the tiniest fractures inside the rock could be disastrous for the towers.
We do not want to make any fractures. We cannot have any fractured rock because obviously that would affect the strength and would create a weakness in the rock. What are we up to next, mate? What's next stage?
Naturally occurring hairline cracks run through the rock. Emma's team will cleverly use these existing fissures to break the stone out.
So it's taking this corner out, basically?
Just checking that out to get back.
And then what you weigh?
To extract every ton of gritstone for Sagrada Familia, Emma is relying on blast engineer Mick Tootle.
We say there's no pressure, but all down to one man, little Mick.
You're going to drill an hole and then you put your charge in. It's very low explosive, but it won't do any more damage than what the rock's already got originally. It's delicate touch to it rather than a massive blast. That's the beauty of it, like.
The explosion frees the 10-ton block. Now Mick must carefully tease it away from the rock face.
Or it'll be like a tooth. It'll be jammed in and you'll have to riddle it. You want it intact, fracture-free as you can. It looks all right to be. You can't see any hairline cracks in it, so it should cut all right. And then off to Spain. And then they can put it in the cathedral.
Mick and Emma must deliver almost 120,000 tons of stone for Sagrada Familia. Every block must be flawless.
We do go as fast as we can, but it is a very precise process and it's something that can't be rushed. Being a small family-run business over here in Lancashire, it is quite humbling, but also very satisfying that we're supplying the stone to complete the most photographed religious monument in the world.
The stone is shipped to this yard just outside Barcelona. Before they build the towers, Fernando Villa must check each batch of stone is strong enough to keep the towers from falling.
Sagrada Familia is forever. Our responsibility is to make sure that this stone is forever too.
Fernando's team drill out a core sample from the stone.
This test is to crush the piece.
Each of the tower's stones must be able to withstand at least 15 tons to be strong enough to become part of the structure. Using a stone compression testing machine, they increase the pressure.
"30 tons, the pressure on the piece. It's amazing. It's the double of we need. It's not possible that tower falling down. It's not possible.
The stone passes the test. Now they can start work erecting the 6 central towers. It's taken over 3 years of detective work to figure out exactly how to design and assemble the tower's intricate stonework. That's because the tower's height and dimensions were a complete mystery. Few clues survive, such as this silhouette sketch created in the early part of Gaudi's life for a completely untested design that seemed to defy physics. This is one other clue that the team had to go on. A model built around 100 years ago. The model is of a small squat tower called the Sacristy that Gaudi designed to be built at the rear of the basilica. The Sacristy also holds the key to the shape of the church's 6 main towers. Architect Esteve Humbert has been trying to unlock its secrets.
These small bits belongs to the original model. Just by having a small bit of a surface, we could reconstruct the whole thing.
Esteve's team used the model to build the full-size 130-foot-high Sacristy tower. It's grafted onto the west side of the basilica and is home to Sagrada Familia's team of architects.
We have 4 main disciples of Gaudi who worked and lived at the time he was working here in Sagrada Familia. So Gaudi talked to the followers or the disciples to use the sacristy as a template for the main towers.
The secrets of the main tower's dimensions are contained in the geometry of the smaller Sacristy tower. So Esteve uses powerful software to reproduce the Sacristy geometry.
So what we have to do was to stretch the geometry of the sacristy to be able to build the main towers, just by changing its proportions.
He designed the towers following the Gaudi drawings and following also the model of the sacristy that contain the way to design the towers.
Meticulous detective work may have revealed the blueprints for the 6 towers, but building them will take some ingenious engineering. In the beautiful, peaceful Catalonian countryside, the tower's construction is well underway. The church's city centre plot is crammed, so workers pre-assemble sections of the towers at this open-air site 50 miles away.
Here you can see it's like a factory. Here we build the Sagrada Familia.
In charge of turning the architect's plans into reality is veteran builder Jaume Torreguitart. He's working out how to build the towers at high speed.
We have to use a new technology. We don't need to work like 100 years ago.
Hoisting every stone for the towers up to the top of Sagrada Familia individually would take almost 50 years and require around 14,000 separate crane lifts. So Jaume's team plans to build the towers in small sections called panels. 16 blocks of stone make up these panels. 8 panels make up 1 tower level. Once a level is completed, Jaume's team needs to truck the panels to Barcelona. On site, they plan to use a crane to hoist them up to the top of Sagrada Familia and slot them into a steel frame. This clever technique should allow them to construct the towers 16 times faster than building them block by block.
We will build the next 3 years 836 panels. It's a lot of work in less time.
Jaume's team is at a critical phase. It's building the first panels for the first tower. They assemble each panel against this green frame. It ensures that all 8 panels fit together perfectly.
In this panel there are 16 stones. We put the stone in his correct place, put the mortar, and it would be in his place forever.
4 bolts will lock the panels into the steel frame on the tower. During installation at the top of Sagrada Familia, 250 feet above Barcelona, every bolt hole must align to the millimeter, or the panels will be left hanging.
we work with only 1 mil of tolerance in all of this piece. If we can't fit them, it will be a very, very, very big problem.
Surveyors use lasers to check the dimensions of each panel, to be sure the bolts will fit and secure the panels in place on top of the tower.
If we have any difficulty to introduce the bolt, disaster, obviously, we cannot afford any delay, any disaster, any mistake in our construction.
It takes 3 weeks to build the first level of panels for the first tower. But will they align? The batch of panels survives their cross-country trek and arrives in Barcelona undamaged. Today is the day of the big lift. This is the ultimate test. Jaume's team must hoist each 7-ton panel 100 meters to the top of Sagrada Familia, slot them down into a steel holding frame, then bolt them into place. Only then will they discover if the bespoke construction theory works in practice.
Well, today for us is a special day. For us is a proof, because it's the first time that we are going to assemble this piece in its correct place.
Jaume's crew secures the first panel to the 140-meter high tower crane built into the basilica.
Y un poco carro atrás.
They hold their breath as the lift begins.
We are going to assemble the first panel.
Jaume races the panel to the top of Sagrada Familia to oversee its installation. Lining the panel up with the tower's frame on its walls takes expert skills.
Vale, centra més al ponent, que hem d'anar més cap allà. Vale, i sí, segueix manant el José. 15, 10, sigue, José, sigue, y quieta. Well.
The first panel fits, and the bolts slide into place.
This is the real proof that the system is a very good system. This piece is here forever. Forever. Well.
But the build team can't rest. They want to install the entire level, 8 panels, before nightfall. But just as they start to lower the second piece down into place,
Vale, José, seguimos bajando.
They hit a problem. This set of bolt holes doesn't line up.
We don't know why, and now we need effort a bit more. All the team working hard.
This monumental build hangs in the balance.
We only need a 10th part of 1 mil. Less than my head.
They use clamps and wrenches to wrangle the panel into place. Some extra muscle power finally forces the bolt holes into line.
We have need a bit more time, but at the end, this is in its correct place. Breathe deep and try again. This is the result. Happy.
Jaume's crew pushes hard to install the remaining 6 panels that make up this tower's first level.
We are going to take them and we want to lift up quickly.
Their innovative prefabricated panel building technique seems to be working. It takes the full day to slot all 8 panels that make up the tower's first level into position.
We learn every day another new system, another new technology.
Completing work on the towers will take almost 6,500 tons of stone. Emma's team at the Lancashire Quarry has their work cut out to keep supplies rolling so construction can stay on track.
We cannot keep up with the demand from Barcelona. As fast as we can produce, they're using it.
The quantity is
good.
A geologist from Sagrada Familia makes regular visits to check the quality of the stone is consistent.
It is a critical job because the towers have to be structurally strong, and this stone is the only stone that they found to match the original.
the quality of the stone is perfect.
Once each batch is signed off, some of it is delivered to these expert craftsmen in Barcelona. They shape each piece based on the team's study of Gaudi's models and sketches.
When you are working with the stone, it's like a connection. You speak with it and it speaks with you.
Galician stonemasons Emilio and Alessandro are sculpting flowers, leaves and letters that will form part of one relief for the tower exterior.
It's a very big job. To do all these stones by hand will take half a year, yes? If I have to do all by hand.
To speed up the operation, highly specialized robots form the rough outlines of the flowers and petals.
Robots never make mistakes. Very precise and very quick, and cut the stone like butter. Robots never take a siesta, so they are always working, and Sagrada Familia needs a lot of stone and needs very quickly.
But robots can't replace the dexterity of the human hand. Once cut, it's down to Emilio and Alessandro to turn the inanimate into art.
The robots, they don't have feel. And we bring the stone alive. We bring the stone alive, working by hand.
Smooth surfaces on the leaves and petals make them look closer. Deeper, harder chisel strikes give the impression of distance and depth.
It's like magic, no? The 3 dimension.
With the help of the robots, Emilio and Alessandro inch closer to completing the complex stone relief. During the tower design phase, engineers faced another critical challenge. They had to be sure that the towers would be earthquake-proof. Europe has 1,100 geological fault lines that trigger up to 300 earthquakes every year. The taller the towers rise, the more vulnerable they become to tremors that might strike the region. Forces pushing from the sides of the towers, like earthquakes, could cause the panels to collapse.
Any lateral forces like wind or earthquakes will make these blocks fall easily.
Howe's team need to squeeze the blocks in each panel together to increase the rigidity of the towers.
So if we put the blocks in compression, we can avoid that these blocks collapse with the wind loads or the earthquakes. And then this is stable. There's no way this can fall.
The easiest way to compress the stones in each panel would be to wrap them in steel cables. But this would ruin the look of the towers. They must look like stone from the outside. Another option would be to brace the towers from the inside, building a supporting frame of steelwork. But this would block up the space needed for the spiral staircases.
You can connect to the steel columns to hold the panel up.
With help from a team of British engineers, the architects devise an ingenious solution that won't compromise Gaudi's design.
So when we have earthquakes, this steelwork gives us the ability to bend elements and absorb energy.
Their solution is to incorporate a secret steel skeleton inside the tower's stone. Sets of steel tendons will run through each panel. Tightening these tendons will lock the stones together. Once locked into the hidden steel frame, the towers look like solid stone. They can now resist almost any lateral forces, such as high winds or earthquakes. That's the theory. Now they must put it into practice.
We're gonna begin production, and it's time to see in reality how does it work.
At the prefabrication yard just outside Barcelona, Jaume's team must thread these stainless steel tendons down through the next batch of tower panels. Workers use hydraulic jacks to press the blocks together to form a solid unit.
After the press, all the 16 stones that they are in this panel is only one piece.
As the jacks squeeze the panel tight, the team tighten the nuts at the ends of the steel bars running through the blocks, locking them in place. On site in Barcelona, the next batch of earthquake-proof panels has arrived. Now, Jaume's team must begin building the larger tower at the rear of the temple. Each of these panels weighs 10 tons, 3 tons more than the panels of the smaller towers. That's a lot of extra weight to keep under control.
The enemy today for us is the wind. A strong wind can take down the crane.
Heavy onshore winds blast the city, and gusts at the top of the basilica are far stronger than at ground level.
At the moment, the wind is correct and we are going to start.
Crane driver Jose scales the 460-foot high tower crane. Not a job for the faint-hearted. If the wind catches the 10-ton panel, it could act like a sail, swinging wildly out of control, smashing into the basilica.
Imagine if the piece would fail with 100 meters high, it would be really horrible.
It takes a steady hand to guide the first 2 panels into place as the wind slowly picks up. As the gusts hit 37 miles per hour, Jaume gets some bad news. The winds are too strong to install the panels.
We can lift. It's impossible. I don't make the lift. The wind is growing up minute by minute. I don't know. We have to wait.
The following day, the gusts die down,
Vale, José, puedes ir bajando.
and Jaume can continue to push the towers skywards.
We need the best weather conditions.
Touchdown. And with its steel tendons secured, this piece of Gaudi's sky-high jigsaw should be able to take a pounding from the winds and earthquakes for centuries to come. As the 6 central towers continue to rise, another team is hard at work, making the ornate stained glass that will sit inside some of the windows. The church's visionary architect, Gaudi, left barely any instructions for the stained glass. So it's down to glass artist Joan Vilagrau to devise a design Gaudi would approve of. He's worked on this giant glass puzzle for the last 18 years and is passing his skills down to his son, Tony.
Del Sant Esperit, que és aquest que estic treballant. My grandfather was a painter. My father was a painter. I am a painter. Tony is working too in paintings. I couldn't imagine that the effect of the colors could be so deep in the people visiting the Sagrada Familia.
The nave of Sagrada Familia, completed in 2010, showcases some of the 17,900 square feet of stained glass contained within the basilica. The light streaming through colors the pillars and walls.
I walked in and it was like goosebumps. Just so completely blown away by the light, the color, the structures.
Choosing what colors will be in one side and another was to create a kind of mystic ambience.
In the morning, the sun shines through the east side of the nave, bathing the basilica in blue light. In the evening, the space turns red as the west side illuminates.
It's the normal changing of the colors during the day. The constant discovery of new effects of the light depending on the hour of a day.
Workers use traditional stained glass techniques to realize Joan's designs.
The techniques in the production of glasses are totally the same in the Middle Age. The way to make the glass have changed a little.
Finally, Joan and Tony's beautiful windows can be installed in the towers. Outside, the team is picking up the pace erecting the church's towers.
Vale, José, sigue subiendo.
This new stonework will add an extra 6,500 tons of weight to the roof. That's almost as much as the Eiffel Tower on top of the building.
Will be extraordinary. When the towers will be finished, the image of the Sagrada Familia will change.
Supporting this immense weight creates a huge challenge. The builders of traditional Gothic churches found an ingenious solution to support their towers. This is Cologne Cathedral, which took a staggering 632 years to complete. It's currently the world's tallest twin-spired church, soaring 515 feet high. The incredible structure was made possible by using flying buttress technology, huge stone arches that prop up the cathedral walls. The buttresses transfer the weight of all the stone down into the ground and stop the structure from collapsing. When complete, Sagrada Familia will soar 50 feet taller than Cologne Cathedral. Its pioneering engineers needed to find a way to support the towers, but they faced a conundrum. Gaudi hated flying buttresses. He considered them to be ugly, unnatural crutches.
We need to support them. But this is not only a question of weight, also is a question of form.
The arching effect of flying buttresses would have transferred the weight above down into the ground. But the buttresses would have blocked the light streaming through the stained glass windows and ruined the effect of the facades. So Gaudi moved the arches inside the basilica and supported them with 56 massive columns. Ahead of the curve and almost 100 years before the tower build began, Gaudi had found a way to channel their weight down into the ground and free Sagrada Familia from the flying buttresses.
No buttresses. The columns will support the towers. All the elements that you look in the navel of the Sagrada Familia have a structural function. It's extraordinary. It's a very ingenious.
The 4 columns taking the heaviest load beneath the main tower are made of red Iranian porphyry, one of the strongest stones in the world.
The architecture of Gaudi is an architecture of the synthesis of a structure and of the forms, and the result is the beauty.
Thanks to Gaudi's forward-thinking design, when topped out, the world's tallest church towers will have all the support they need. Finally, after 135 years, an estimated £900 million, and a whole lot of engineering ingenuity, workers here have decoded the maverick and mysterious vision of Gaudi.
It's a big honor and a big responsibility to feel you are part of a history developing this project.
It's not simple, but I'm sure that my generation can see the Basilica finished.
The team is well on their way to finishing Sagrada Familia's massive crowning towers, to finally complete this extraordinary structure in time for the centenary of Gaudi's death.
The tower is growing to the top. If Gaudi look this tower, perhaps he's looking. I think Gaudi will realize his project in the construction. I feel that we are continuing history.
Known as God's architect, Gaudi is famed to have said, "My client is in no hurry." But it won't be long before Sagrada Familia is complete, and Gaudi's client will have the world's tallest church.